Hi there, chemistry kids. I want to spend another little quick chem minute talking a little bit about volume and how to measure volume in the chemistry lab. It's going to be a technique that's super important, and really we use it quite often even in our everyday life, especially at home. The thing about measuring volume in the chemistry lab is about precision. It's how precise is your equipment. And that's a big, important factor. So we have lots of different ways that we can measure volume. So probably the easiest is using something like this at home. And this is basically a measuring cup. And you can see there's some graduated lines on there. And that graduated line just means there's a step level. And but you can also see in between the graduated line, there's a lot of empty space. That's not a super accurate measuring device. But if you're making mashed potatoes at home or making soup, that's good enough, right? Next, kind of working our way down in the chemistry lab, we have this what's called a beaker. Okay, the beakers have about the same size opening as the bottom. There's really no change in shape. But again, if you notice in the beaker we still have graduated lines, but the space in between those lines is quite large. As a matter of fact, the numbers on there, they're reading about every 50 milliliters, but there's a little space in between there, about every 25 milliliters, we can get an accurate volume. But again, down to the decimal on milliliters, probably not the way we want to go. Going down a little bit more precise, we have what's called a graduated cylinder, and you've probably seen these before. Again, it is graduated. You see the numbers on the side there, hopefully. Okay, and this one will get down, you can see the numbers are reading 10 milliliters a piece, 30 to 40, but it does have graduated marks in between where we can actually read 1 milliliter at a time. The precision on this will give us 1 decimal point, so I can actually measure 35.5 milliliters if I wanted to, with that last decimal kind of be an educated guess because there's no hash marks on it. Zoom in a little bit more on graduated cylinders. We can get even smaller, a little bit more precision with the graduated cylinders. And again, looking for better data, better measurements. Okay. Now this is what we call a volumetric flask. Okay, note the flask has got a smaller head with a wider base. That's basically what a flask is. Okay. On this one here, there's only one line on there. I don't know if you can see it. It's right up here where my finger is. One line. And that line is exactly 100 milliliters when you get there. Okay, so measuring a very, very precise measurement, we could use this volumetric flask as well. The smaller the neck is, the more accurate your measurement will be. Again, we're going to read on the meniscus of the water bubble as it sits on top, the water level. And when that bottom of that bubble hits that line, that's pretty accurate to be about 100 milliliters. If you want to be super accurate though, we could use something that's like this, which is called a volumetric pipette. Okay, and again, just like the last one, there's one little itty bitty line up here where my finger is, and that will measure out 10 milliliters very, very super accurately. And we can even use some pipette helping devices here to just make sure we get as close to 10 milliliters as possible. There are lots of different ways to measure volume and take volume. But again, in chemistry or any science class, in order to be as accurate as possible with the data, we need to be as precise as possible with the measuring devices. Okay, if the measuring devices have really big gaps, we're going to have a lot of error in our data, and who knows how good our data is because of those measuring mistakes that we made at the very beginning. All right, a little chem tip on how to measure volume.